Okay, so let's start workshop 4, convolution neural networks. So actually, we already have seen neural networks in last workshop. In last workshop, we already seen neural networks. Like Vivek has already explained you how neural networks work and how they are used for classification and regression tasks. But why do we need convolution neural networks? What's the necessity of it? The main necessity is to reduce number of parameters. Okay, let's see how many parameters are required for normal neural network and how many parameters are required for convolution neural network. For suppose, let's say there's a data set which contains 4 features. Here you can see in the purple color, like these 4 features. Let's think you have a data set. Suppose let's say you need to predict predict the rate for a house. So features may be place of that house and the number of rooms, square, so area of that, or something like that. Let's think there are 4 features. So you have 4 neurons in the first layer, and for every 4 neurons, let's say this is x1, x2, x3, and x4. For every x1, x2, x3, x4, there are corresponding omega 1, omega 2, omega 3, omega 4, which you need to multiply, add it, and get single value for the next neuron. Like you will get a single value with 4 parameters: omega 1, omega 2, omega 3, and omega 4. In the similar way, you need to take different omega 1, omega 2, omega 3, and omega 4 to get the second neuron. In that way, if you want totally six neurons in the second layer, for every neuron you need 4 parameters and a bias, so totally you need 5 parameters, and for every neuron you need 5 parameters. There are 6 neurons here, so total 5 into 6, 30. So for one layer you're requiring 30 parameters, and that too if the number of features is 4. So for 4 features to construct a single layer, you're taking 30 parameters. Imagine an image, like image, for suppose let's say image is of 265 into 260 length and 265 width. So you will have 265 into 265 parameters, and every pixel contains red, green, blue value. So every pixel contains three values. So that total 265 into 265 into 3 parameters. So for 3 into 265 square, the number of parameters for creating a single layer would be huge. It would be very large. You can't work with that many parameters. You need high computational resources to work with that many parameters. So hence, to reduce the number of parameters, we use convolution neural networks. Let's see how convolution neural networks helps in reducing the number of parameters. Okay, let's see. Like in convolution neural network, there's a filter. There's a three. So here we can see a 3 into 3 matrix in middle with -1 0 1 -2 0 2 -1 0 1. This is a 3 into 3 matrix, and let's think the whole big matrix which is there backside is an image. So you have an image and you have a 3 into 3 matrix. This 3 into 3 matrix is called filter or kernel. This kernel and filter is the important aspect of whole convolution neural network. This decides the output of the convolution neural network. For suppose, let's say the size of it is 3 into 3. No, it can be anything, 5 into 5 or 7 into 7, anything. It should be square. It should be a square matrix, and for suppose, let's say it's a 3 into 3 matrix, and this is also some big matrix, and this image is also a square image. So convolution neural networks are only applied for square images. Let's think this is a square image, and there is a square kernel here. So you multiply the value of pixels with the values of kernels. Here it's -1. Here it's -1 0 1, -2 0 2, and -1 0 1. So hence this -1 is multiplied with the first value 3. This 0 is multiplied with 0. This 1 is multiplied with 1. This -2 is multiplied with 2. This 0 is multiplied with 6. In similar way, you multiply all the 9 parameters here with the first 9 numbers in the image. You get a number, like you multiply all the elements and add it, like you'll do 3 into -1 plus 0 into 0 plus 1 into 1 plus 2 into -2 plus 6 into 0 plus 2 into 2 plus 2 into -1. Similar way, you'll add everything, you'll get a number which is -3. The similar way, you will just use the next square. Here you can see, right? See, you can see here this first you multiply with this square, you get a number. Next, you move the square by 1 unit, multiply it and get one more number. You move the square by 1 unit, multiply it, you'll get a number. In this way, from one 2D matrix, you're creating another 2D matrix. Like, but the size of it is small. Like for every 9 elements, you're getting a single element here. So the size of it is reduced too much. So the main aim of convolution neural networks is to reduce the number of size, so that if the number of parameters are reduced, if the number of features are reduced, then automatically the number of parameters required for a neural network would reduce, and hence at last we can simply use a neural network. So a main aim in convolution neural network is to decrease the size of dimensions of the features. Like here it is, here for every 9 elements you're getting a single element, so automatically the size of the image is reduced to some number. Let's say if the image is 256 to 256 and you're multiplying it with 3 into 3 kernel, you can easily see that the size of image would reduce by maybe by 200 to 200. Like it reduces the size. In a similar way, you apply the same operation with this matrix, you reduce it further, same operation again with the output, you reduce it further, and maybe suppose, let's think from 256 to 256 size, you applied all those mathemat all you applied the same operation with a kernel, and finally you got some 10 into 10 size matrix. So you take this 10 into 10 size matrix, throw it in this neural network and get the output. If the number of features for this neural network is very less, then automatically the number of parameters would be less. So the basic aim of convolution neural network is to reduce the dimension of the image, because images has many parameters. If size of image is very huge, the number of features in it is very huge. So extracting the important features from it and reducing the dimension of the image is main aim of convolution neural network. So let's see how convolution neural network extracts the important features. Here we took the example of -1 0 1, -2 0 2, and -1 0 1. But these numbers are not fixed. These are the parameters of our model. Like let's suppose I initialize randomly with these numbers. We have to minimize the loss. Just we do in this neural network. We will do backpropagation. Just we do it like this in neural network, which you have learned in third workshop. We do all the backpropagation stuff similarly, and we minimize the loss with gradient descent steps and find the optimal numbers in these kernel. So every structure is totally same to the neural network. The only difference is we try to reduce the dimension of the image. Like we at the end, see the input is 28 into 28 into 1 image. We apply the convolution properties and finally we got it into 4 into 4. Like we use this final 4 into 4 features and throw in this neural network to get the output. So basically instead of throwing this 28 into 28 into the neural network, we just input the 4 into 4 matrix to the neural network, such that the number of features required for this neural network would be minimized. So basically the dimensionality reduction step is done by convolution networks, and the classification step is again done by the neural network only. So I just want to stop here for 1-2 minutes so that you can digest whatever things I have told. I hope everybody are following. You could ask any doubts here. You can unmute and ask if you have any doubts. Even you can keep in chat too. Okay, I guess there are no doubts. Let's move forward. So yeah, like there are some standard architectures and standard ways convolution neural networks are used. Like for example, here you can see there's a 28 into 28 image, and we are first reducing that image to 24 into 24, then to 12 into then from into 12 into 12, then 8 into 8, then 4 into 4, and finally using a fully connected neural network, which you have learned in third workshop, the same thing, and finally classifying it as a number. Like here we can see 2. So output should be output. The probability of getting 2 should be high. So output here, output of this red neuron 2 should be high than the other things. So there are some methods along with the filter multiplication here, which we have done. There are some methods in which you can reduce the image from the large image to the small one. The first one is padding. Okay, first one is max pool. Like in this filter, we have just multiplied the value here and the value in the image. But in max pool, we just take the maximum. Like for suppose, if I take a 2 into 2 kernel and I want to suppose I'm taking 2 into 2 max pool, so I'll just take a 2 into 2 square, write the maximum value here. I'll take the 2 into 2 square, maximum value is 30. I wrote here 2 into 2 square, maximum value is 112. 2 into 2 square, maximum value is 37. In this way, I'll just write the maximum value in every 2 into 2 matrix. If I write the maximum value of every 2 into 2 matrix for 4 numbers, you are writing corresponding single number. So in this way, you're reducing the size of image. Here it's 4 into 4, and here it's just 2 into 2. So you're reducing a 4 into 4 image into 2 into 2 image. So the same way, if we do the same steps here also, like here we have multiplied the number here and number here. In the similar way, if I consider a 2 into 2 matrix which contains four numbers, and I multiply those 4 numbers with these 4 numbers, I also get the same. I also get the 2 into 2 matrix, but with different numbers. Only numbers change, but with both ways we can reduce the dimensions of the matrix. So these are some two methods which are used to reduce the dimensions of matrix. And accompanied with these, there are some methods called max pool, methods called padding and stride. These are some methods to improve the convolution networks. Like for suppose padding adds a layer of zeros around the image. Like this is a 3 into 3 matrix. If you apply one padding on 3 into 3 matrix, all zeros are kept here. Like here you can see there are zeros around the image, and the image is at the center. So padding basically adds zeros around the image, and the use of it is to, sometimes the size of image. Suppose let's say if the size of image is 5 into 5 and the kernel image is 2 into 2, so 5 is not divided by 2, right? So when you're applying this multiplication step, the last at the last step, your kernel could not get all the numbers because it's 5 into 5 and 2 into 2. So at last the last row would get left. So instead of leaving that last row, if we add zeros and then apply convolution network, we can also consider the last row too. So we are not allowed to remove the last row of it, so that image becomes 4 into 4 and kernel is 2 into 2, so that we can, so it's divisible, 4 is divisible by 2, and we can apply the convolution. We cannot do that, because if we remove the last layer, we are removing the information, which is not good, because we have to keep all the information in our model and then train. So instead of removing the information, we just add a layer of zeros around the image, so that we can, instead of removing the last row, we just add the layer of zeros, so that we can multiply the filter. We can multiply the filter. And there one more thing called stride. As you can see here, the square box is moving one row to the right. So it's just moving one row to the right, and one is called the stride of it. So if I keep stride as 2, then the square box would move 2 units to the right and then multiply. If I keep stride as 1, as shown in this animation, it's moving 1 unit to the right and then multiplying. So in this way, stride is used. Here you can see this red box is that first row and first column, and the green box is that third row. So it's moving 2 units further. So the stride of this example is 2. Here you can see here also, like it's this square red box and blue box. Here it went down, it went in the column below, two columns below. So the stride is 2 here, and the input is 7 into 7 image, and the output is 3 into 3 ways. So stride affects the dimensions of the output. Obviously, padding also affects the dimensions of output because you're adding zeros around it. And obviously, kernel also affects the dimensions of output because you are because here the 9 into 9 3 into 3 all 9 numbers are kept as single number. So the kernel size, padding, stride are major factors to decide the output volume given the input size. So for that we have some formula which is W minus K plus 2P by S plus 1. This W is the input matrix size, which is the size of image which you are giving. K is the kernel size. Here we took 3 into 3 kernel. P is padding. As you can see in this animation, padding is 1. Here you can see in this animation, padding is 1. See here there are white boxes which corresponds to 0 here. So the padding is 1 here. Here also the padding is 1. And the next thing is stride. Here you can see in this stride is 2. In this animation, stride is 1. So using the input size matrix, kernel size, padding, and stride, we can calculate the output size of the network. Like here you can see here, it's 28 into 28 is changed to 24 into 24. This value 24 into 24 can be obtained from this formula. So using this formula, we can see what's the dimension of the next layer, and we can decide how much we need to reduce the dimension, how much we need to decide. We can decide what should be the kernel size, what should be the padding, what should be the size, what should be the stride according to the next layer's dimension. So these are some of the main things which we do in convolution networks, which are kernel multiplication, padding, stride, max pool, and this is the formula. There are some other topics also which we use in convolution network, like we use batch normalization, we use many other topics which I am not going to cover due to time constraints. I will give you a link. I'll give you resources, you can see that. And next is, let's see how convolution neural networks work. Let's see how convolution neural networks work. Like here you can see there's an architecture. Here you're giving it 227 into 227 size image, which is convoluted with 11 into 11 filter with stride 4, and there are 96 of such filters. Like see here, one filter has gave you a one matrix. If I keep 10 filters, it would give me 10 matrices. Here in this example there are 96 kernels, so I would get 96 of these type of matrices. So the output here is 96, and you already saw by using this formula you can calculate this 55 into 55 size. So here 227 is convoluted with 11 into 11 with stride 4, and there are 96 kernels, so the height of it is 96. So you can see here 227 minus 11 by 4 plus 1, the same formula is used, and we got 55. In this way 55 is reduced to 27, 27 is again reduced to 27, it is again reduced to 13, and net weight class reduced to 6. This 6 into 6 into 256 is flattened to get 4096 features. These 4096 features are dumped in the neural network for classification. So this is what we actually totally do in convolution networks. So let's plot these middle matrices. Like we'll plot these middle matrices, represent them as images, and see what convolution neural networks are actually learning. See here you can see 55 into 55 into 96 size matrix. This 55 into 55 into 96 matrix will be plotted as an image, and we can visualize that image. See here you can see there are images, there are multiple images. These are the images in between convolution layers. Like this image is the visualization of this output. This image is visualization of this output. So in this way, if I go on see the visualizations of all of all outputs, what I get is, let's say this is the image. For suppose I gave some input and I got this as an image. Here you can clearly see there is some line and there are some lines like this. From our visual perspective, we can clearly tell this as a feather. So if I give this as an input, the output of convolution network turns out to be this. So I kept a feather image in this. After totally training, after completion of training, the output of this 6 into 6 image is this. So here you can clearly see it is extracting the important features of this, like this line, this small hairs here. So the same thing we can visualize here. See, there are some lines like this. There are some hair in it. So feathers. So the important features of feathers are extracted here. Similarly in this too, like there is a chain. There is a chain, and here also you can see pattern of chains here. So every chain you give as an input to the neural network will be represented as this type of matrix at the output of the convolution network. See, like when you give a input of chain 227 into 227 image, the last 6 into 6 image looks like this for all types of chains. For all type of feathers, the last 6 into 6 image looks like this. So in this way, it's extracting the important features from all the from from the image given. So and it can classify, and it is thrown in neural network so that it can classify. As already important features are extracted, neural network could easily classify this as whether it's a feather or it's a chain. So in this way, convolution neural network works. There are many things which are going behind the convolution neural networks, like there are many methods and there are many mathematical concepts involved. Why we are choosing this type of kernel only? Why we are choosing only square type of kernel? For all those things, I'll send you resources. If you are interested, you can read. Because of time constraints, I'm totally avoiding maths, and I know we have many first years present there, so I am not involving much maths in it. So this is the totally outline of convolution networks. So till here, any doubts? थोड़ा सब कुछ समझ में आ गया सबको? अरे कुछ तो बोलो, समझ में आ रहा है नहीं आ रहा है? फास्ट 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 जा रहा है या स्लो? स्लो बोलो, कुछ तो बोलो.
हाँ भैया कॉन्सेप्ट
If
समझ
you
आया.
don't understand anything now, because it's somewhat complicated, I'll send you resources. There are many lectures, like Andrew NG lectures are there. There are many YouTube videos also. You can refer them.
भैया
Yeah.
Audience,
so I have doubt like how will we applying like in a code? Like I understood the concept, but how will we applying this in the code? Like how will we code this?
Yeah. We are coming to that. Next part is the code part only. Till now in the concept, if you guys didn't understood, ask doubts in that. Code is the next part. Vivek is going to explain the code.
Okay. भैया.
so if no one has any doubt, we are ready to forward to the code application. Wait, let me share my screen. Is my screen visible?
No.
So basically, it's the code for the artificial neural network. We will be first showing
Look,
you
visible
how
नहीं है
to build
screen.
a neural network. First of all, क्या शो कर रहा है स्क्रीन पे?
नहीं कुछ आ ही नहीं रहा, स्क्रीन शेयर ही नहीं हो रहा.
स्क्रीन शेयर किया था मैंने.
Guys, wait a minute. He has a network issue. He'll rejoin again and share it.
स्क्रीन विजिबल है?
हाँ हाँ अभी विजिबल है।
कोलैब दिख रहा है?
हाँ हाँ दिख रहा है।
हेलो, स्क्रीन कोलैब दिख रहा है क्या?
हाँ हाँ दिख रहा है दिख रहा है। हेलो हेलो Vivek, you're not audible.
Sorry for the first of all, we try to build a basic neural network. So as we
अरे
discussed
अभी
in a
तुम्हारा
previous
कोलैब नहीं दिख रहा है। हाँ हाँ अभी दिख रहा है।
visible है?
हाँ हाँ अभी विजिबल है।
So first of all, we see a basic neural network. This I can show you how the neural network actually do the prediction. First, we give it an and then make a prediction according to its initialized weight. False, we define a loss function according to that, and it's try to optimize by the background and it updates the layers over here. So first of all, we import the here we import the pandas, and here we using the TensorFlow. So I discussed the TensorFlow mainly used for machine learning in Python. So we import TensorFlow, Keras from the layers and those further. So this is how our data set look like. From -5 to -5, and the
क्या
classes
स्क्रीन फ्रोज हो गया है,
blur.
स्क्रीन फ्रीज हो गया है। वो फ्लो चार्ट ही दिख रहा है अभी भी। Okay, he has network issues, so I'll only share and continue it. It's visible, right?
Wait a second, it's loading. Yeah, visible now.
Yeah, okay. So this is actually Collab notebook. I guess you all know it. In first workshop we have used it. So we are going to explain you the simple neural network, how to implement it with TensorFlow. TensorFlow is a library. TensorFlow is a library which is basically designed for neural networks and for deep learning stuff. Like we have sklearn and other stuffs for basic machine learning algorithms. We have TensorFlow and PyTorch for deep learning methods. We are going to use TensorFlow. We are going to teach you TensorFlow, how to build a neural network in TensorFlow, how to load the data, how to split the data with how to split the data as training and testing data, and everything which requires to basically classify do a task in deep learning. We are going to totally tell you in TensorFlow. If you are interested, you can study in PyTorch also. And we are only going to tell you normal neural network, and your assignment will be is to implement a convolution neural network. There wouldn't be much big difference in both. Only a two three changes would be there in the model. Only 2 3 changes in the model, and you need to just write the just call the function CNN so that it would add to your model. So let's see how it works. I connected to this. I connected to the Python server. See, I'm importing all the libraries here. See, I'm importing pandas, NumPy, TensorFlow. See, TensorFlow has something called Keras. Keras is also a Python library. It's also a deep learning Python library, but it's an outdated library, and there is a layer outside the Keras which is called as TensorFlow. So Keras is an old library. Around those old library, there are some functionalities, there are some improvements which TensorFlow has done, and the whole library now it is called as TensorFlow. So we are importing Keras. This is layers. We would see what this layers means. You would see what this train and test split is. Okay, first I'm just importing the data. Wait. Okay, wait. Vivek, can you send me the data?
Yeah. Wait.
Okay, actually, this data.txt. We are loading the data.txt here. You would send me the data. I'll load it and show you. So you can see here. This is the graph of the data. So it contains two classes. One class is of red and one class is of purple, and it contains some two features. So those both features are between -5 to 5. You can see here. So both there are two features. No, one two features, and the values of two features are between -5 to 5, and the features are and the data is plotted in this graph. And you can see here, this red part is of one class, this purple part is of another class. So there are two classes in the data, and we need to classify this type of data. So there are two features, and data contains two classes. Each feature is between -5 to 5, -5 to 5. Okay, moving on above it. Okay, let's first see how to build a model, and then after getting the data, I'll show you how to split it and how to split it and how to separate the labels and the data. We'll see what's labels, what data, and everything after we get the data set. I'll just show you first how to build a model. See, model basically contains layers, like how many neurons you need to keep. See, these how many neurons you want, how many initial neurons are present in the how many features are present in data. That should be the number of neurons in the first layer. How many neurons you want to keep in the second layer, third layer, and so on. So that's the first parameter you need to decide, layers. Second thing is activation functions. As you would have learned in third workshop about the activation functions, like which are used to it is a property of layer which are used to introduce non-linearity in it. You need to decide loss function, which you have seen. I guess you have learned mean square error loss. You have learned categorical cross entropy loss in second workshop, and you have to decide an optimizer. I guess we have taught you gradient descent optimizer. There are many other optimizers present, but for now we'll only use gradient descent. If you are really interested, you could read about the other optimizers as well. See, there are some activation functions like sigmoid, relu, softmax, swish, and linear. These are used to introduce some nonlinearity in the neural network. And there are losses: mean absolute, mean square error, binary cross entropy, categorical cross entropy, sparse categorical cross entropy. These first two losses are used for regression tasks. This below three are used for classification tasks. I guess everybody know what mean square error is. I guess in second workshop binary cross entropy has been covered. So we are just limited to these two losses only. If you are interested, you can explore other losses also. Their optimization. We are limited only to gradient descent. If you are interested, you can search about these things also. So okay, let's see how to build a model. In We are building a model using Keras, which is inside the TensorFlow. Like there is a Keras library. Around the Keras library, some functionality improvement is done by TensorFlow, which became the TensorFlow library. So from TensorFlow library, I'm importing Keras, and we'll use this Keras to build a model. So I'm using Keras. See, I'm using Keras, and already know our data contains two features. Both are between -5 to 5. So for the first layer, the input would be of shape 2 comma 2 comma 1, right? So this contains the input shape, and this is the output shape. So you can see here there are 4 neurons here, but in our data set there are only two features. So here there would be 2 neurons. Here we have kept as 4, right? So I kept here as 4. So this here we would have 4 neurons. So the first layer contains 4 neurons, which input is the data features, where data contains only 2 features. So the input size is 2. We have written 4 here because I want to keep the number of neurons in first layer as 4, and I used activation as relu. So this is the first layer which we are preparing, and after the first layer, which has 4 neurons, I want to classify it. So this is the second layer I'm preparing it. Okay, this is the second layer I'm preparing it. So second layer contains 2 neurons. So if I just so you need to write this part: keras dot sequential brackets, square brackets, and just write the square brackets represents list, as you already know from first workshop. The square brackets represents a list. So you need to write the list of layers in keras dot sequential function to decide a model, to decide the architecture of model. So this model contains 4 neurons in the first layer, 2 neurons in the second layer, and the input size is 2. The activation of first layer is relu, activation of second layer is sigmoid. So in this way we define a model. In this, and for compiling model, you need to write model.compile. It is optimizer. You can use any optimizer you want. Here the optimizer used is Adam. If you want gradient descent, you need to write gradient descent here. I'm using Adam here because I wrote Adam. And the loss is here, you need to write keras dot losses dot sparse categorical and cross entropy loss. So the loss I am using here is sparse categorical and cross entropy. If you want to use by simple simple cross entropy or binary cross entropy, here you need to change the function. And metrics, this metrics is like metrics accuracy. So what actually this metrics do is, in the every epoch you need some parameter to judge your model is performing well or performing bad. You have the loss function value. So the whole aim of machine learning and deep learning anywhere is to minimize the loss. So you can print loss after every epoch and check is your model really reducing it, or you can print or you can print accuracy and check if your model is doing great or not. So for evaluating at the every epoch, I keep this matrices value as accuracy. So at every epoch, I will get the output accuracy of the model. So this model dot fit x, y, epochs, and batch size. The model dot fix here x contain. I'll talk about this x and y. Okay, let's talk about this x and y now. see here you have a data set. I don't have this data.txt now, and Vivek has some network issues, so he can't send me. I'm not able, so I can't download it. So I'll send you this. We'll send you this collab notebook. We'll send you this data.txt also. You could run and check it. So after this command is used for loading data.txt. This is pandas. You're reading it as CSV. This is data.txt. So that data has two features between -5 to 5. And next thing you're doing is splitting the data. So splitting the data as train and test split. So what exactly train data and test data? Train data is the data on which you train the model, and test data is a data on which you check the accuracy of the model, so that you can know your model is doing best or not. See on train data, definitely your model should do best, because that's the data you gave for the model to learn. But we want the model to generalize it. Like if I give an example of cats and dogs, I gave 10 cat images, 10 dog images, and I made it to train. But if I give an image which is not one of the 20 images I gave it, should also classify it as correct. So this test dataset is the dataset which I don't give during the training part, and I test the accuracy on this dataset. So train and test split is done this way. Train test split is a function. We have passed the dataset here. The test size 0. 0.2 means 20% of data goes to train test set and 80% of data goes to train set. Ignore this random state for now. Actually, random state randomizes the data. I don't think it's much needed now. And shuffle is, ignore these two parameters for now. If you are really interested, you could search these parameters and know about it. But for now, ignore these parameters. We'll just concentrate on these both. Like this is the data and this is the test size. Test size 0. 0.2 means 20% goes to the test set and 60%, 80% goes to the train set. So now this is constructing the x and y values. See, actually what data contains is it has two features. So it will have two values. Let's say your data is 0. 0.2, 0. 0.3, and it also contains a label. Label determines it is a red color or purple color. So data contains two features and a label. It determines it is red color or purple color. So maybe for red color, let's say it's 0, and for purple color, let's say it's 1. So all the zeros and ones should be stored in y, and all other features should be stored in x, and this x comma y combined should be sent through the model so that it can train. So you need to send to the model separately. Like labels are sent to the model separately and features are sent to the model separately. Like y is labels and x is features. So labels means the class. Like here red for 0, 0 for red and 1 for purple. So y contains zeros and ones, where 0 means red, 1 means purple. So okay, any doubts still here? I guess everybody are able to follow. Okay, moving forward. So if I don't have dataset, so I can't run everything here. So if I just, this is the model part, this is the compile, and this command trains the dataset. This command trains it. So model.fit is used to train the data. It is trained on x and y. It has 10 epochs. So we are sending 10 epochs, so it trains for 10 times. And batch size, ignore this parameter for now. Batch size is something like, batch size is something used in this batch gradient, stochastic gradient descent and batch gradient descent. We don't use that in normal gradient descent, but ignore this parameter for now. If time permits, we'll cover this in the next workshop. If not, we'll give you a resource and you can see it. So in this way you can train the model, and this is the model for testing it. And this is done for testing the models. Like you separate x and y for test data. This is test.x.values, test.y.values. You separate x features for test data. You separate labels for x data. send x comma y, and this is batch size, ignore this for now, and you use model that evaluate. See, evaluate means it prints you the accuracy of the model. Like till here your model has totally trained on the trained data, and now you are predicting the values of labels for test data, and you're evaluating the model. So evaluate gives you the accuracy of it. If you're able to achieve high accuracy in train and test model, then your model is performing better. Like here we have taken only 2 layers. So if you want, you could take 4 layers also. Here first layer contains 16 neurons, and input size is obviously 2 because our dataset contains only 2 features. Then 16 is increased to 32, 32 is again kept 32, and 32 is at last decreased to 2. So this is a better model than before because we are increasing more number of layers. See, more number of layers introduces more nonlinearity in the model. So because here you can see the data set, it's highly nonlinear. You can't classify this data with a single straight line or some combination of 2 3 straight lines. It's highly nonlinear. Maybe you need to classify like this. You can see my cursor pointing arrow point cursor, right? So maybe you need to classify like this. It's really complicated. It's not at all linear data. It's highly nonlinear data. So for highly nonlinear data, it's better to increase the number of layers. Like here you're using 16, 30, and this number like 16, 32, 32, and 2, this number is not fixed. You can change anything, experiment with the values, and get to the best one. So here the values are experimented, and we found the best configuration of model for this type of data is 16, 32, 32, and 2. So hence this has kept as a model. Same thing is done again, compile. Same thing is done again for train. Same thing is done again for fit. This is the same thing is done again for evaluating a model. So this is the whole thing which you need to do to construct a CNN model. So construct a normal neural network. Similarly, to construct a CNN neural network, instead of dense here, you need to write CNN here. This is the only thing which is different. Instead of this dense, there is a different function for CNN. There are different parameters for CNN. You could easily explore it. Will give you resources, and that would be your assignment for this workshop also. There's not much no much big difference between normal neural network and CNN. Just the function call is difference. Here we use dense, which represents normal neural network. There you use CNN, which represents convolution neural network. The only difference between two is only that one. So you can just change your dense to CNN and create a CNN neural network. And the one more difference present is here we give you the output size, right? So here we give you the number of neurons in first layer, number of neurons in second layer. So here we write the number of neurons. But in convolution neural network, there we would write the activation from where you would write the kernel size. Like here you saw in the PPT this size. This size 3 into 3 is given as a parameter to the CNN function. The other things are all same. So in this way we will code neural networks in TensorFlow. The same thing is all we can do in PyTorch also, but that's somewhat complicated than this. So if you are really interested, you could read it. You can read it. There are many YouTube videos. I'll send you in the resources too. Yeah, that's it. I don't have the dataset, so I'm not able to run it and show you. We'll send you the dataset too. I'll send you this collab notebook also. Just click runtime, run all. Everything would run, and you could just compare the results of these both model too. Like this model only has 2 layers. This model has 4 layers. You could see how the accuracy has increased or decreased, whatever you feel, whatever it happens. Actually accuracy would increase because you are increasing the number of layers. You could increase this 32 number to different number. You can experiment it, and you can find when you're getting more accuracy and when you're getting less accuracy. Okay, yeah, that's it about the code. Any doubts? Okay, then we'll wrap up here. If you don't have any doubts, you can leave, or else you can stay and ask them.